So today I'll be showing you guys how to solve Hardy-Weinberg problems, and things you have to know to solve this is the equation first: p squared plus 2pq plus q squared equals 1. P squared stands for homozygous dominant, q squared stands for homozygous recessive, and 2pq stands for heterozygous. P stands for equals dominant allele frequency, and Q equals recessive allele frequency. Another thing you have to know is that P plus Q equals 1. Okay, off to the example. My example is 15% of the population are blind, and those who are blind are recessive. With the Hardy-Weinberg problems, you usually get to 1 to 3, maybe even more questions. So for the questions I came up with is number 1, what percentage of the population are blind? Number 2, what is the frequency of the dominant and recessive allele? Number 3, what percentage of the population are heterozygous? These are probably the most common questions they'll give you. So for number 1, it's pretty much common sense. What percentage of the population are blind? It's right here, 15%. That's the answer for number 1. Number 2, what is the frequency of the dominant and recessive allele? For this question, you have to find Q. And to find Q, you square root Q, and you will get .3. And once you get 0.3, and once you get Q, you can get P, and P will equal 0.7. So for the answer for number 2, it would be 0.3 and 0.7. So off to number 3, what percentage of the population are heterozygous? For number 3, you have to use the formula, you have to use 2pq, and then you just plug in P and Q, so 2 times 0.7 times 0.3. Once you multiply all that, you get 0.42. So when you go back to the problem, what percentage? They want a percentage. So go percent. Your answer for number 3 is 42%. And that is how you solve a Hardy-Weinberg problem.